engineering. Just before I introduce myself, I saw my president walk in, Engineer Dr. Ribeiro. A round of applause to him. He is the chairman of the Ashanti Regional Branch of GHIE, that's the Ghana Institution of Engineering. Sir, you are welcome. All right, so I'll proceed by inviting our Dean, Professor Francis Kemalso, to give us a welcome and opening address. A round of applause as he mounts the stage. Don't stop till he takes the microphone from him.
Good morning. So the provost is away and he's asked me to represent him here and to give the welcome and opening address. I want to make it as informal as possible, but I see a few dignitaries here. So let me start with Chairman 1, Chairman Ribeiro. There's also a few from Genser, Anna. There's Henry. And then I saw Fritz earlier. I'm sure he's here. And my colleagues who are here, Director, Profiteria, and the rest. Distinguished guests, students, and friends. I don't know if there's anyone from the media, but anyway. So I don't know. I'm a bit young, but also mid. I remember when we started working here, like, what, 18 years ago, right? In those days, we had this passion for renewable energy. We still do. Those were the days of Jatropha. I was a pioneer for Jatropha biofuels. We were running all over the place, trying to promote Jatropha as the miracle crop of those days. Recently, I saw a video of me, like a 13-year-old boy, talking about biofuels and Jatropha on YouTube. But yeah, we did quite a lot of that. Those led into government attempting to do like policies for biodiesel, for biofuels, etc. Unfortunately, those policies, etc., they never saw the light of day. Everything just went kaput after all the work we did. And then so we had to move on and move into other areas of research. Then came 2011 when we had the Renewable Energy Act, right? That act, right after signing that act, I saw on the news that they were going to construct some 330 megawatt solar plant in Winneba. That plant never took off. So quite a lot of things that were supposed to have happened in the past did not happen in Ghana. So frankly, when I saw that we were going to build a gas pipeline, there was same, like, yeah, it's one of those things in Ghana, but it did happen. And Genser Energy did make it happen. I think we should give them an applause. Yes, I'm excited to be here today that after all the failures of the past, that one did happen, and Genser did make it happen. And so, on behalf of the College of Engineering, on behalf of the Provost, I am delighted to welcome all of you to this important lecture on the theme is Fueling Ghana's Future, Engineering Excellence in Natural Gas Infrastructure Development, and the title is Industrialization, Building Ghana's Natural Gas Highway. Now, today's gathering reflects our shared commitment to advancing engineering excellence and sustainable energy development in Ghana. We are honored to host key stakeholders from academia. I can see my colleagues here, from industry, and also the research community, especially our partners from Genser Energy, whose collaboration continues to inspire innovation and practical solutions in the energy sector. As we explore the transformative potential of natural gas infrastructure, let us engage with open minds and a shared vision for fueling Ghana's future. I encourage all of us to contribute actively to the discussions and to take full advantage of the insights that will be shared. I don't want to talk for long. I want us to move straight into the discussion. So thank you very much for joining us, and I wish all of you a fruitful and impactful session. Thank you.
Thank you very much, Prof. Kemalso. We have gathered here for a lecture, a partnership between KNUST and Genser Energy. To hear the background of this lecture, I have the honor to invite Professor David Kwanzaa to give us the background of this gathering.
Thank you very much. So thanks once again. The background to today's event is quite recent. In December last year, there was a meeting that took place in the office of the provost. Genser visited, so it was actually their initiative. They visited the college. And at this meeting, very important discussions were held. I call it a very fruitful discussion. But this is the College of Engineering. We don't just talk, we want action. So 3 action items were produced from the meeting. We realized that it would be good and beneficial to have staff and students visiting the facilities of Genser. It will be good for the study of engineering and for what we do here. So we agreed to do that. We also realized that Genser has been a very important player in the energy sector, implementing some landmark projects like what we are coming to hear about today. And so we would be implementing technical seminars and having guest lecturing arrangements by Genser staff. And there's a third one, which has to do with doing research on subjects of mutual interest. So this is about 8 months ago, and I am pleased to observe that 2 of these have been accomplished. In June, that's last month, a team from this college comprising staff and graduate students, research assistants, visited the gas facility owned by Genser. So that has been accomplished. Today, we are having a technical seminar. So at the end of today, at the end of this seminar, we would say we've accomplished 2 out of the 3 activities we agreed upon. But of course, these are not one-off events. The hope is that we would be doing this on an ongoing basis. So let me at this point express gratitude for the hard work that has gone into this. Dr. Jebre did a lot of work. Dr. Jebre, let's see you. Yes. Dr. Jebre and Fritz have exchanged probably over 100 emails to ensure that things get done. So their tireless effort is very much appreciated. Now to today's seminar. It's basically what I call a celebration of engineering excellence. We are also celebrating brilliant young Ghanaian talents, many of whom passed through this institution and sat where you now sit as students. Today's seminar is also to let you know that what you do here is not just some fanciful theory, but in fact is fundamental knowledge that is critical for industry practice. You would find that pipeline diameters are not chosen at random, and that what you do in fluid mechanics and compressible flow find daily application in industry. So thanks once again to Genser for coming at your own cost. And special thanks to, we have a committee on seminars and workshops at the Brew-Hammond Energy Center, led by Dr. Kilson. Please, Dr. Kilson, are you here? So Dr. Kilson and his team have worked very hard. There is Dr. Sefako. Please, are you here, Dr. Sefako? I saw her. Yes, thank you very much for the hard work. And Dr. Sebastian Palo, if you are here, okay, he's not here. So they've put a lot of hard work into this. When we announced this, some students asked me whether there will be item 13. So let me assure you that thanks to Genser, item 13 is massively assured. So Fritz will explain to Anna what item 13 is. But for now, don't tell her. Thank you very much.
Thank you very much, Director, for giving us the background to this lecture. And one thing he said that I will echo again is the fact that the theories that you learn have a solid basis. Okay, once you get it strong, you'll be able to effectively practicalize it. So when you are taught, don't assume that we are wasting your time with plenty theories. You will need it. And as he speaks, he will elaborate more on that. Thank you very much, Director. The next, we'll have an address from Genser Energy, and this will be done by a team member from the External Relations and Communications from Genser Energy. And he is in the person of Fritz Tuwohofo Moses. Such a beautiful name. Let's welcome him. Obiantu ne hofo waha. And ne lecture we mu. Everybody to hofo. Advise yourself. Let's keep clapping. Welcome, brother.
Hi, good morning, everyone. Thanks very much, Dr. Emanuela, for the introduction. Once again, my name is Fritz Moses. I work with Genser Energy's External Relations and Communications team. My very brief presentation will be about our industrial training program. So essentially what Professor Kwanzaa spoke about, where we had some lecturers or faculty members and graduate students visit our ABMS. That's the Aomaso branch and metering station, just close to you here. It's a part of a program that we run in Genser Energy that we call the Industrial Training Program. In essence, the program is to bridge the gap between academia and industry, where we invite some of you, and I believe that some of you have already participated in this program. We had a first session with KNUST, specifically with Dr. Jude and students from petrochemical class. And so we are excited to introduce this program to you and see how beneficial it will be for both parties going forward. Now, the presentation, as I said, will be brief. I'll just highlight the program, and also we'll let us see how participants from KNUST have fared and how we've also undertaken the program, and of course, the next steps that we look at. Like I mentioned earlier, the program is to provide technical training for the students on campus. This training is typically handed down by our engineers. So typically what we would have is a few students will go in for about 2 or 3 hours in a day. You would have a full lecture in class about the energy industry, Ghana's energy industry, where Genser fits in, and what we do depending on the specific sites that you've been to. So if you've been to our ABMS site, you will get to learn about how pipeline works, how the natural gas flows, and the various components of the station, and what each of that does for our operations. And so we started this training somewhere last year in May. Like I mentioned, the first session was with KNUST. Dr. Jude students came in, and in somewhere around May last year. And since then, we've had several students come in. Currently, we have about 639 participants who have come through the program. Specifically from KNUST, we have about 144. Now, going forward to not only on-site training at our various sites, we also have sessions where our engineers will come to your campus to speak with you or speak with some select students. And what we've done, an example of that is in earlier this year, or late last year, somewhere in November, we had one of our engineers in Takoradi. So he spoke, he's a senior naval engineer at Genser Energy. He spoke on marine oil and gas operations, terminal operations to the oil and gas, the terminal marine oil and gas science department in TTU, that's Takoradi Technical University. And it was a phenomenal event. That's one of the some of the career fairs that we also participate in. Quite recently, too, in February, we participated in a career fair with senior high schools in the Western region, so specifically around the Ahanta West area. Now, going forward, we are looking at how we can continue our faculty sites visits, specifically extending it beyond the faculties in just the engineering, the College of Engineering. Then also, of course, also see how, like we've already mentioned and we are doing today, bringing our engineers on site to speak to you and answer your questions and see how relevant what you are learning is to industry. And looking at the participation, for KNUST, we've had, like I mentioned earlier, about 144 students participate in the industrial training program. For our records, most of the students have been, or the participants, because we have some faculty members too there, have been males with about 97 of them, and 47 being females. Now, majority of KNUST students have been visiting our ABMS, that's the Awomaso branch pipeline, branch metering station. And we are glad that that is the case, and of course also glad that it was KNUST that set the pace for our industrial training program. Then of course, we've seen like the uptick of university participation. Following the success with KNUST, with your colleagues, your friends, your mates, we've seen the University of Mines and Energy, Mines and Technology also participates. We've seen TTU, like I mentioned earlier, University of Energy and Natural Resources, who came from all the way to Sunyani to visit our sites and learn all that we do, spend about 3 hours or so on site, following and learning from our engineers. And so it's been a very fruitful engagement with our engineers and students, yourself, on our sites. We're hoping that this series of public lectures that we've started today would go on to also bear fruits, as we've seen in the on-site visits. Now, of course, like I mentioned earlier, for next steps, we are looking at continuing our faculty trainings and looking at possible research collaborations between Genser Energy and, of course, the College of Engineering and the Agriculture, Faculty of Agriculture, to ensure that we are still, of course, able to collaborate. Aside from the trainings that we give to students, we also see some faculty assistance in some of the research or some of the things that we do on our operations. And specifically also to increase our partner institutions. We understand there are several institutions, or the technical universities in Ghana, that we would very much want to extend this training also to. And so, of course, we are open to that partnership and looking to bring in more institutions. Of course, currently we have about 10 technical universities KNUST Technical University, definitely we are looking at bringing them to on board and seeing how this can also benefit their students and how we as Genser Energy too can benefit from it. And so this will be the end of my very brief introduction to our industrial training program. From there, we would move on to the main reason why we are here, the main person for today's event. And so thank you very much.
Thank you very much, Fritz Moses, for elaborating on the partnership so far. Some students have taken advantage of it, and I hope the rest of us will also do same. Their doors are open, so after you can engage and see how best you can also maximize the opportunity given to us. So I acknowledge here one of my brothers, Dr. Jude Kwekubonsu from the Department of Chemical Engineering. Kweku, you are warmly welcome. So to do the introduction of our speaker will be Engineer Dr. Joseph Ribeiro, who is the chairman of Branch 1. That's the Ashanti Regional Branch of GHIE. And he's also a senior lecturer in Kumasi Technical University. Chairman, you have the floor. A warm welcome. Keep clapping, that's my chair.
Good morning, everyone. I hope we are fine. It's important to be. I am honored to be asked to introduce the main speaker. In fact, this morning I met him. And usually when you meet, I've realized that when you meet very important people, they can be very unassuming sometimes. So I'm just honored to share his profile with all of us. And I'm sure at the end you'll agree with me that he's a celebrated and talented engineer. So our speaker is Henry Abeku Opong, and he's experienced and skilled in project execution, energy and sustainability, program and project management, construction management, negotiation, cost engineering, constructability and strategic management. And he has built more than 420 kilometers of natural gas pipelines and 23 natural gas stations in Ghana. I'm sure there's been some elsewhere. And not only that, he's also built some national gas supply interconnections to VRE, AKSA, and Senate power plants at Aomaso Power Enclave. Our speaker excels at accelerating project life cycles through active coordination between engineering and construction teams. His passion for talent development and talent building fosters a collaborative environment that drives success. Furthermore, he's a continuous improvement champion, ensuring projects are delivered on time and within budget. I hope you run for office one day. His leadership expertise has demonstrably benefited Genser Energy Ghana Limited. He possesses a strong academic foundation, holding a bachelor's degree in civil engineering from KNUST. I thought you would clap for KNUST. And further specializing in energy and sustainability with an MBA from the University of Cumbria, England. With 15 plus years of experience, Henry is a seasoned engineer. He's presently the Vice President Operations at Genser Energy Ghana Limited, with a core focus on natural gas sales. I believe now you'll agree with me what I said earlier, that we have a talented engineer in our midst. At this particular point in time, Ella, I believe I can bring our speaker. Yes, so with a huge round of applause, let us invite Our speaker. Oh, let's keep clapping till he gets here. Pleased to meet you, sir.
Thank you very much. Good afternoon. I'm honored to be back to my alma mater here. And when I came in this morning, I wanted to roam around and take in the air, and it took my mind back to the times when we were here. I left KNUST 16 years ago, 2009 specifically. I was in the Department of Civil Engineering, and I was inspired to read civil engineering back in the days for a number of reasons. I wanted to be a research person, probably working on scientific related researches, because I had great interest in chemistry. But looking at my love for mathematics, I thought I could be part of something bigger in Ghana and in the world in the years to come. So I focused on the civil engineering. It was very difficult. It requires a lot, but thanks to our lecturers, and I remember one of our active lecturers, Dr. Adoma Samoa, was always there. We look up to him a lot. I left and I wanted to be part of something bigger in Ghana. I wanted to join a global, ambitious group of people who are looking to solve some of the issues in Ghana and beyond. So after school, I joined Genser Energy as part of the graduate training programs. I think we were the pioneers of the Genser graduate training programs, which is still contributing massively to talent acquisitions and talent development. I was called to be interviewed by the CEO himself, who was a product of MIT, I think the best engineering university in the world. You could imagine the stress and the pressure on your shoulders meeting such a person for the first time. But meeting him, all I was given was a marker to go to the marker board in his office. And the first question I had was, I'm involved in this project and I want to complete this project within 6 months. I left school. I knew basically nothing. Confidence was not there because you basically do not have the knowledge to be able to face the challenges out there. So, zero knowledge, zero confidence. What is there that they are looking for? I believe that they were looking for some natural trait, some soft skills that you left school with. And being natural with some of the difficult questions I faced there, I think I was able to survive. The interview was on Friday. I started work on Monday. With time, I'll actually delve into the programs and the structures in Genser that made us who we are. It didn't come out of anything automatic, but we emerged where we are now as a result of discipline, developing certain important career values like credibility, how trusted you can be, and how reliable you can be. These were some of the basic blocks of characters Genser leadership built in us that made us who we are today. I will quickly introduce Genser Energy, what we do, and then talk briefly about how we helped in building the largest pipeline transmission system in Ghana. And I'll also talk briefly about the alumni of KNUST who played key roles in the development of this infrastructure. And then we'll talk about how we assembled a group of young engineers from KNUST, UMass, and the other universities, UNR, and how we worked with very experienced engineers from Europe, Asia, America, and how they impacted us to be able to come up with the biggest natural gas pipeline network in Ghana. So here we are. Genser has been in the system for the past 18 years. We started from Bogoso. We built power plant in Bogoso mines. We came over to Unilever. We built 5 natural gas power-fired plants in Takwa Damai, Edikai mines, Chirano, and then we eventually built 3 phases of the natural gas pipelines and all of that. We also are into the gas midstream. We are building the biggest natural gas processing plant in Ghana, which is in Pristia. We are also into cryogenic storage plant system. We are building a natural gas liquid terminal in Takoradi. We are also into natural gas pipelines, operations and EPC. We are mainly EPC. Under EPC, we do all of these stuffs. Before I hint on our big stories, I would like to introduce you to the natural gas infrastructures we have in Ghana. Basically, as you can see here, this part of the Ghana map is concentrated in the western part. In the natural gas infrastructures, we have the midstream, we have the upstream, we have the midstream, and then we have the consumers who are downstream. We have more than 3 offshore gas fields. We have 10, we have Jubilee, we have Sankofa. And then we have the 4th, Block 4, which is recently discovered. Now, this make up the upstream. And we have a gas processing plant at Atwabo that is owned and operated by Ghana Gas. So far, it has been the only gas processing plant which can do only 150 million scf. Now, the question is, why natural gas? Before that, Ghana was operating, utilizing heavy fuels, HFOs, like diesels and whatsoever, until 2000 and mid-2007, there we started discovering these fields. Now, these fields, 10 and Jubilee, make up the Greater Jubilee, which can, and then Sankofa. Greater Jubilee actually extracts associated gas. Normally, when they discover it in the wells, it comes with some oil, some crude oils. So these are usually treated at the GPP1, the Ghana Natural Gas, GNGC GPP1. They treat it, they extract all the crudes and gather pure methane, that is natural gas, and then transport them through the red pipelines all the way to Takoradi and then to Pristia. And then Ghana as a country, our power generation systems predominantly rely on natural gas. And in the whole country, we need about 460 million cubic feet every day to be able to reach the power producing, the peak demand. But unfortunately, we have only GPP that can do only 150. And then Sankofa also extracts lean gas, dry gas, directly. And together with Greater Jubilee, they are able to provide 380 guaranteed supply every day. But we are not able to meet the 460. So what happens? We have to build and coordinate with we had the WAPCO pipeline, the West African Gas Pipeline. That is a green pipeline coming all the way from Nigeria to the coast of Takoradi, and then Tema. So this gas pipeline supplies the deficit that we have. That is 460 minus a 38, that's 80 million scarf. We buy them from Nigeria. So what does that mean? What it means is that Ghana needs to develop more processing capacities to be able to utilize what we have offshore in the wells. So thankfully, Genser is building 200 million cubic feet capacity of natural gas processing in Prestea. And in the future, GPP, Ghana Gas is also adding a second GPP that can also do another 150. So that gives us huge hope to utilizing the natural gas that we have. So that means that Genser came up, just GNGC were able to build their gas pipelines to Prestea, but there was no consumer. It's just there. What does that mean? All the excesses has to be flared. Before 2021, 2019, Ghana was flaring about 47 billion cubic feet of natural gas, which was equivalent to $300 million wasted. So Genser came up, and then we built the first phase of the pipeline to Takwa Damai. That was 80 kilometers. And then we continued with the second phase, and the target was to get to Kumasi. Kumasi is the region that can connect the north easily. So by the grace of God, we've been able to build a pipeline all the way to Kumasi. That makes up the 430 kilometers. And then we have ATSCA, we have Senate, we have VRA relocating all the way from Tema to Kumasi because they will have access to available gas. And that positions Kumasi to be the new Tema. You have access to huge energy infrastructure revolution. So that's what you can see here. So in the future, the North can easily be linked, and that could revolutionize industrialization because we need energy to be abundant to be able to grow our energy infrastructures. So this positions Ghana to increase our speed in industrialization. So this is what we've done. There are a number of records that were set with the pipeline implementation project. We used 6 months of construction time, to implement the phase one, which is very unusual. And the second phase, which was around 335, we used a accumulation of 9 months to build all the 235 kilometers. And then when we were coming to Kumasi, we also used 6 months to build 110 kilometers of the natural gas pipelines. This natural gas pipeline revolution that was brought by Genser Energy was as a result of some of the alumni from KNUST, very young. By the way, the average age of the staff in Genser Energy is 32 years. So, okay, thank you. The average age of the Genser staff is 32 years. So that creates an environment for young people like me and you. I'm not so far, you're not so far from me. You come there, you see a lot of young people like Frick, a lot of young people like Deborah Cromwell, making decisions with them, sitting down. So it gives you that freedom, right, to express yourself. This guy up there, that's me. 2017, he had no knowledge, no experience about natural gas pipelines. What does it mean for Genser Energy to appoint you as a construction supervisor at that time? I started as a construction supervisor or a senior construction supervisor. What does it mean for the company to appoint you to lead a project you have no idea or experience on? Genser Energy create an environment where they push young guys like you and me to hit and discover our limit and then push over the limit. What happened after I was appointed to lead it? I was taken to China for a number of times. The Chinese learned very much from the Germans, from the Americans, and they are really efficient at what they do. They are really disciplined at what they do. Genser took us to China for a number of times to understudy the Chinese industry. Some EPC giants like Sinopec, CIMC, Hontu. You will have to sit, learn, relate, and then you come back with that experience to help grow the young ones that are disposed to the project. When we started the project, I made mistakes. One of the mistakes that made me who I am, it is through mistakes that I learned. One of the mistakes that made me who I am was during the phase one, we were supposed to, the CEO, the top management gave us a straight line, pipeline, from Pistia to the destination, Stakwadamai. It's a straight line that gives you, the lowest pipeline route to take. But at that time, you've not mastered the act of right-of-way selection criteria and what it takes to say that the pipeline pass here and all of that. The challenge is 28, they have their own budget. But you will have to come down and learn with this big giant like Sinopec to really train you, and you learn a lot, and then you come back and write your report. Hey, we cannot go here because the selection criteria according to this code and standard says that the pipeline should be away from the communities by 200 meters and all of that. It shouldn't go over the mountains. It should stay by the toes of the mountains. And before you realize, you're getting 80 kilometers. So the expectations of your top management is 28 kilometers, but the site investigations and the engineering standard tells you that you will need 80 kilometers to get to your destination. So that is why you will have to take your engineering codes and standards very serious right here, because as an engineer, you are required to have your level of technical acumen. When you are up to select a right-of-way, the right-of-way selection will tell you and inform you on what class of pipes you are supposed to procure. And all of that, I'll come back, I'll hit on that. So I made this mistake, and we directed the pipeline into an active mining concession. The width of the right-of-way didn't meet the standards, which was between 25 and 30. And we had to come back when the mine stopped us. Hey, where is your EPA permit? Where is your ECR that you did and all of that? We had to come back, and before we realized, we had to reroute, and a reroute will already cost us as well. It costed us half of the money we've spent so far. So I was there one morning, CEO called, the top manager called, hey. And you know what it means for top management to call a young guy like you and me at that time. It's 2017, he was shaking. Henry, you are fired. You are fired. To you, you know you are doing all the things you had to do, blah, blah, blah. You had to went to my room and cried. I knew I was putting in a lot and all of that, but that was the time I learned that it is very important for you as a young engineer to also understand the expectation of your management, right? Understand that these decisions you take will affect this decision you take will lead to this, and all of that. So, what is next? A few people in our team had to step in, right? And I was given a second chance, and I vowed. That was when I vowed in my room in Takwa that I will have to make sure that my decisions in every little detail is guided by standards, by codes, by the expectations of the corporate environment, the expectations of stakeholders. You have to start looking at a bigger picture, start guiding your team as a leader. When even, you have to understand that if your team member even commit a mistake, you'll be responsible for it. So you have to pull your arms wide open and ensure that every single member of your team knows how to make healthy decisions. So that was how we started springing up. Fast forward from the you are fired in August to October, I was promoted. The difference between these two situations is dedication, discipline, not giving up. In the times where things are difficult, you have to rise up more and put up the very best of your attitude and be a better professional within this. And what does it mean? There is this guy called Stephen A.C. He left KNUST in 2017. He joined Genser, graduate, the SEO graduate training. He came in as an assistant engineer, nothing. Just like Terry there. I mean, these are high flyers, these four guys. They came in just like you. Genser will give you the platform to express yourself. They'll give you the room to make your mistakes. And if you're smart enough, you learn from your mistakes. Right? So this guy started from normal construction supervisors, assistant supervisors, and now they are all superintendent. Stephen is 30 years, Terry is 30, very young people. Now before I zoom into the natural gas, how we did it and all of that, just appreciate these young faces here. Michael Jojo Smith joined the Genser Gado training in 2013. He rose up through the ranks as a chemical engineer. He became our community relations superintendent and then rise all the way to the ranks of the community relations management. He's been part of all of our natural gas pipeline projects, but he had to, leave us and go to school. So and then we have some other young guys from UMAT, Emmanuel Boateng, who is also currently, flying. We have Eddie, he joined as a QA/QC associate. He also led the quality assurance related objectives or expectations in the project. We have Tometa, a civil engineer who is now part of the business development, a senior business development, and we have Daniel, a civil engineer who is now part of the GCP. All these guys are, most of them, about 90% are KNUST alumni. We have Cornelia. Cornelia joined recently in 2022. She was part of the Kumasi Pipeline project. You could see these young faces. Rahima, Walter, Isaiah, who is now an operations superintendent. They all started with us. Good. So how did we form the team that was made up of a lot of KNUST alumni? We built the team within the pivot of 3 areas. We we were committed to their capability development. We also focus on maintaining execution culture, how we do, how we deliver, ensuring that the delivery is, is delivered through effectiveness. And then we also focus on monitoring the performance of each and every person. We look at what you are supposed to do, what you did, how much you're able to implement the project with, plan, actual budget, and all of that, review your performance, give you new taxes, supervise you, give you time, and ensuring that all these things are done properly. So during the team mobilization, the main feeding area is a Genser SEO graduate program. I don't know how many of you are members on campus. How many of you are aware that SEO Africa does recruitment in KNUST? How many of you are aware? Just a few people. So SEO gives opportunities to you on campus to apply. You have 2 years to join even after you leave campus. And they are focused in ensuring that soft skills are properly impacted into you. And then we work with SEO to recruit all of the candidates who will be successful across Africa: Ghana, Ivory Coast, South Africa, Nigeria, and then Burkina, and then most of the countries who participate. We get the best out of it, and we have 100% retention. Genser is growing. We have a lot of room for people. We believe in young talent. They come in, they go through their 18-month rotation program. You'll be exposed to 6 months in the EPC area. You'll be exposed 6 months in operations, 6 months in corporate. By the time you are done, we see you as someone who is ready to take on full responsibilities. So we champion a lot of talent from the SEO graduate program with core focus on students who are adaptable, who have the essential soft skills, and who have basic communication skills to build on. And we mix these people with experienced engineers from Africa, Asia, and America, and they ensure that they are well supervised and they are well trained. And what makes them who they are, as I said, was that they were exposed to projects in China. They worked with Sinopec to develop our first feed, and then the selection criteria in our right of ways and all of that. And some of the basic soft skills that, software skills that you need to develop is some survey, ArcGIS, CAD, AutoCAD, Google Earth. These are very primary. And as you can see here, when they come in, we take them through rigorous project management training, in-house shadow training, and all of that to ensure that they are really ready for what is expected of the team. So in what goes on in the natural gas pipelines, we've done 430 kilometers of natural gas pipelines. This involves 24 gas stations. Now what happens? What is required in building, or this is how we build our natural gas pipelines. First, we start with the basis of design, and then we create a basis of design manual. This is where you as a mechanical engineer, you as a civil engineer, you as a control mechanical, whatever engineering field that you find yourself in, all these engineers sit down and then develop the foundation for the detailed design or the detailed engineering of the pipeline system. So this is where you are required to contribute. This is where you are required to appreciate. This is where you will really appreciate all these things that you are learning in school that people actually don't regard. You hear it in the media. What do we do with Pythagoras theorem in real life? What do we do with this fluid mechanics and all of that? What do we do with it? And this is really having huge influence in the behaviors of the engineers when they are in school. They ignore some of these fundamental things. But during the business of design, this is where you will appreciate all those things. In sizing of your pipelines, the pipeline transmission system. This is where you bring in your ASME, B31.8 and all of that. In sizing of your valves and fittings for the pipelines and the this is where you bring your ASME B16.5 and B16.9. This is where you appreciate the gas laws, your Charles laws and your Boyce laws and your rear gas, all these things, because this helps you to appreciate, right? This helps you to appreciate the behavior of gas in certain conditions of temperature and pressure. If you are asked to build a pipeline from Prestia all the way to Kumasi, what does it mean? The challenges that you will face here after your days of design that we actually face has to do with land acquisition, land availability. The laws of Ghana permit people to own lands. The lands belong to the traditional councils. So you need the lands. If you're coming to Kumasi, Kumasi is a high population density area. It is difficult to convince the people to accept the laying of natural gas in their communities to Kumasi. Because you hear of the explosion that happened in Bogoso, Apieche. Yes, you hear of this and we're like, oh no, you're going to kill us and all of that. You go to them and as young people, they see you and then you're like, you the small boys. You think you've gone to school. So you want to come and tell us what to do. Right? The language barriers. You will learn to appreciate the challenges when it comes to entering into communities. As young as you are, they are threatened already. You are telling us to give you our lands, to pass natural gas through it, come and kill us. You have timelines to convince these people. The project has timelines. So this is where you will learn some appreciating other colleagues in the industry, stakeholder engagement. You will learn, despite the language barriers, the tree, the airways, so many local languages, you will still have to, maneuver your way through it. Land acquisitions, you will have to work with Ghana valuation divisions, land divisions, right? Third parties like that. And there are moments when you value their crops, right? You have a budget. They are saying that, oh, we don't care about what LVD is saying we should pay, or you should pay us. We want to tell you what we should pay them. It's a challenge. If you don't complete that process of negotiations, you can't do the pipeline project. You have to cohabit. You're going to cohabit with them, and you need their support to stay. So these are challenges as young people. You have to focus on good interpersonal relationship skills. Focus in appreciating the communication skills that you are learning. Because you're going to, whether I like it or not, when you are put in the field, you will have to bring it into play. So our major challenges that we face was land acquisition, getting the people to accept us, and utilizing your knowledge in natural gas behaviors. Let them understand that it is rare to hear explosions of natural gases and what goes into the pipe selections that will protect the communities. We need 200 meters to lay our pipelines. You have 50 meters. Somebody just bought a land to develop properties on it. How do you convince them to give you your land, to build your pipelines? There are special cases where we had to divert because there's divert, spend more and divert and all of that. But these are some of the challenges we faced. Now, phase 1, 80 kilometers, phase 2, 235 kilometers, and then phase 3, 110 kilometers. After you acquire your land, you will have to have permit, work with the regulatory agencies like EPA. You need an EPA permit, perform your ECR to prove that your project, how your project is going to affect the environment socially and environmentally. You will have to, prepare your ECR report for EPA and make a presentation to EPA to offer you their support by saying that you have our blessing, so go and build with your EPA permit. You will have to identify all the stakeholders involved, like Ghana Gas, who are the national NGTUs. You have to involve the Energy Commission, right, who will give you the siting permit for the project. You will have to involve the people, the traditional councils. You will have to involve all the institutions, the district assemblies, the municipal assemblies, and all of that. Then you will conduct your detailed engineering based on the basis of design. The detailed engineering is done, they bring it back to the engineers to review. And if all the conditions in the engineering are satisfiable by the client, the owner, then procurement comes in, right? So, as I said, your selections of the pipe is based on your codes, your industry codes and standards. We end up choosing either class 1 pipes, class 2, class 3, class 4. If we don't have the lands available, it means that you are passing your pipe through dense communities. You have to consider the pipe classes that will have thicker diameter, bigger pipe thicknesses to be able to make up for the pressure that is passing through the gas pipelines to wherever it's going. Then you will have to do your valuations and compensations. You value the lands. This is where you have your problem, the biggest problems, right? The livelihood of the farmers. Sometimes it's just one. You have to work with the chiefs, the landowners, to replace the farms and all of that. It's not just passing through it, but ensuring that their livelihood is also sustained. Compensate them for the crops, compensate them for the lands, and then when you have them, you start preparing your right-of-ways. Right-of-ways is the path that the pipeline will take. You have to clear, you have to make it motorable, make it conducive for bigger equipment to be able to work on. And sometimes you will end up clearing what you've decided to clear because of, creating mounds and managing the waste and all of that. And you have to pay more to the aggrieved farmers. And sometimes you are working and they come and hijack you as a person. Sometimes your vehicles are not going to move away. Say, if you don't pay me my extra, or I'm not happy with the compensation you've given me, you have to pay me more before you continue your work. And sometimes the whole project team could be hijacked, and you have to come and then ensure that you speak to them and then respond to their grievances with the collaboration of the traditional leaders in the land and all of that. It's not easy at all. So when you are done with that, then we have something called stringing. You line up the pipelines along the right-of-way, and you start putting them together and then start welding the joint and all of that. When you are done, you have to ensure that you test the welding joint to ensure that they meet the pipeline specifications, so that at least the welding becomes, the strength of the welding, it's equal to the strength of the pipe itself. So the pipeline is not subjected to unwanted leakages and all that. That could be a threat to the communities and all of that. Then when you are done, we start with our trenching, and then we lay the pipelines that we've welded together with the help of, series of excavators who are lined to drop the pipeline into the trenches. You cover it in stages. The first stage, you cover it halfway, and then you put the caution tape so that when our issues, Ghana, aside the community issues we had, another bigger challenge was the effect of galamseys around the pipeline. Right, galamsey is a big issue. You will do your right of way, and then you go back and come, somebody is mining the right of way and all of that. So you put the first layer there, a caution tape, in case anybody is excavating the place accidentally, they will know that there is something. You say pipeline beneath this caution tape, at least. And then you do your second backfill. You create a mound over the pipeline to inform people that there is, a pipeline there. You put signages and all of it. And then you construct your gas pipeline stations. You have stations like the block valve stations, which are placed at every 25 kilometers. The purpose of this block valve station is to be able to block the flow when there is emergencies, control the flow of the gas in the pipeline when there's emergency. You can block it here, and when there's a need for maintenance somewhere, you can block it to ensure that there is no flow of gas to where you are maintaining whatsoever. So you do all these block valve stations, you do your metering stations where you need to do it and all of that. And when you are done, you just start with a pre-commissioning. A pre-commissioning means that you need to subject the pipe to certain conditions of pressure. So we use the hydro testing procedure where we pump water into the pipeline, compress it to the design pressure of the pipeline. Normally we do 100 bar, but in the pre-commissioning stage, we actually subject it to more than 100 bar. Let's say 1.15% of the design pressure, and to ensure that the pipeline will be able to withstand the conditions of the design pressure. We hold this compressed pipeline, the compressed water in the pipelines, within 24 hours, and we check every hour of the day to see that the pressure in the system is the same. If the pressure is reducing with time, we know, what does it tell you? The mechanical engineers, if you are holding this, you're holding the pressure in the pipelines, and then you come back after 1 hour. Okay.
Okay, so I first heard it at the Almasu gas station, and then they said if you want to check the integrity of the pipe for a particular distance, they run the pig through, and also it does cleaning. Yeah.
All right, thank you. So as I said, in the course of the cleaning, we have different kinds of pigs. We have a pig to clean the pipeline, to pump the water out and all that. And then we have another kind of pig that tells you that the internal diameter of the pipe is what? Uniform. Right. And there's another pig that tells you whether there are cracks inside the. So what, for example, if you want to check the uniformity of the internal diameter, you send the pig over there. When a pig arrives and it is distracted, right, it's torn, it tells you that there's an issue with the internal diameter of the pipe is not uniform, right? So you do all these pigs to pick up all these informations, and that, as I said, it's all checking the integrity of the pipeline. and all of that. It's also done during maintenance. Recently, we had to do maintenance on the pipelines by ensuring that we don't cut off supply of natural gas. You do the pigging whilst the natural gas is flowing without affecting operations and all of that. So that is it with the pre-commissioning. In the commissioning stage, you also have to ensure that the pipeline is able to flow the lane gas. So we first of all have to purge the pipeline, because once you've cleaned the pipeline, there is oxygen and there is air. You know, the pipeline is exposed to that. So what do you have to do? You cannot flow hydrocarbons when there is oxygen present. What happens to it? You want to help? I want someone else. Who wants to contribute? You finish cleaning the pipeline. You want to flow gas, but you realize that there's a possibility. So if you don't eliminate the oxygen in the pipeline system, what happens? And you flow the gas, you have turned the pipeline into an explosive device. You will be worse than Osama bin Laden. What does it mean? You build pipelines through communities and you are commissioning the pipelines and you don't pay attention to the safety requirement. And these are real issues you can have if you don't pay attention to details. So we have to produce an inert system in the pipeline. What gas can be used to remove oxygen? For example, nitrogen. And okay, so we have to flush nitrogen into the system at a certain conditions of pressure, right? Normally it's 1 to 2 bar. We fill all the pipelines from beginning to the end. We have a nitrogen plant, we fill it to the pressure. And then we hold the nitrogen for another 24 hours by checking the pressure gauges. If the pressure keeps reducing with time, what does it tell you? It tells you that something is leaking, right? There are cases where we've seen pressure reductions. And how do you trace the leaking areas? You are feeding it through you select a station, from station to station, block valve station. So you will have to spread the team in each of these stations at the same time. There's a team manning this station, there's a team manning this station, a team manning this station, and we are communicating. What is the pressure here? You have to drop it on the WhatsApp page that we have. What's the pressure here? It's the same. We are communicating every hour. And when there's a leakage, you have to check all the valves. You have to use the soapy water to be, pumping it onto the valves and to check. When you see a leakage or a loose end, then you tighten it and all of that until the pressure is uniform throughout the hours. And when it's done, we vent. We get rid of the nitrogen by using the vent at the various stations. We vent it out. And when the nitrogen is vented, that is where you bring in the lane gas. You flush the lane gas into the system. And that was what we call commissioning. And this is what we've done between 2017 or 18 till date. And Genser has been able to build over 90% of natural gas pipeline infrastructure in Genser, in Ghana. And we are the only private owner of natural gas pipelines. For me, the take here is, whilst we were done, I was called that, hey, you need to go to Ivory Coast. So I have been sent to Ivory Coast to build over 300 megawatts of power plant that is fueled with natural gas. What does it mean? Someone who has been building natural gas in the key areas of my life, and suddenly you are called to go and do power project. It's another challenge. What does it mean for me? It's an opportunity for me to work with people, once again, who knows much than you do. What has made me, what Genser did for me and made me who I am was they always placed someone above me who knew more than I know. Right? Our CEO knows everything, from finance to every aspect of the engineering that we are doing. He knows everything. And the managers on top of you knows more than you know, even those you are supervising. Those above and those I'm supervising know more than I do from the start. So this gives you a typical natural challenge. What does it mean for people you supervise to know more than you do? Even where I'm going in Ivory Coast today, the one I'm going to supervise has over 25 years of experience in so many areas. And for me, it's an excitement for me. That is what will hasten your growth. It puts you on a pedestal to utilize your time very effectively in developing the areas where you think you are lacking. So the challenge I want to put to you here is that you will have to appreciate the level of detail you are being trained here. For example, if you are being asked in a class to prove that the square root of 2 is irrational number, what do you think they are doing? You think they are wasting your time? Oh, this is too abstract. What am I going to do with it? As an engineer, what am I going to do with it? Do you know the essence of the analysis that you are doing? Even though sometimes it may not make sense to you, how is it applied by what people are saying on social media and all of that? That is a training to give you a pattern, a problem-solving pattern. It trains your mind to be working in a particular pattern of solving problems. Problem-solving pattern. The systematic approach to dealing with issues. So whether something makes sense to you or not, believe me, when you leave school, the industry is waiting for you there. It will wait for you over there. Critical thinking, the analysis, it helps you, it conditions your mind to critically delve into issues. So that is what is making China, China. The guys are brilliant. They are machines in the classrooms because they are disciplined. What you need is to be able to appreciate the discipline ingredient in the training. I hope you get me. Right? I think I will come to the end of this presentation. If anyone has any question here, I believe this is the time and the floor is open for questions.
All right, let's give it up.
Okay.
There is another microphone. Please, if you have any question, you raise your hand and then we'll bring you the microphone.
So please, I have 3 questions.
Ask all of them.
Please, first of all, deals with the fact that there are communities along the route of the pipeline. I want to ask that, are there any measures for them taken in place that they could also enjoy the pipeline through? Taking into consideration that CO2 is produced from fossil fuels, which could also lead to physical hazards and health diseases. Thank you.
Please, how many should we gather in a go? Then you address. 5, okay?
5's okay.
All right. I saw a hand here.
Yes, please. I also have 2 questions, not related to Genser, but then, yes, related to Genser 1, and the second one is not related to Genser. So my first question is, when I looked at the construction, the only thing that I saw that is related to my field was the instrumentation, and I think instrumentation, and I've forgotten the second one, but then it's about instrumentation, which is in my field, that's in electrical engineering. And also the second question is, I saw you attained a master's degree in University of Cambria, and I was asking, is it really necessary or important as a student to only attain, excellence in academia and find partly in your soft skills and all that, and attain first class, or it's not so much necessary to attain first class in your first degree, but still move on further to pursue your master's degree? Thank you.
All right, sir.
The first question was communities, whether they have opportunities to tap from the natural gas pipeline transmission, right? The pipeline is in the community to stay. In the future, when the country is ready for domestications of the natural gas pipelines, the pipeline now has actually put in place the mechanism for it to happen. Genser is undertaking other projects, water supply project. Anna is running that, and she's doing a pilot project in Kokofu and all of that. Is it Kokofu and Kokofu? Yeah, where we want to run water distribution systems to the various homes in the communities. It's some of the experiments we are taking, but for now, we are not looking at that, but the opportunity is there in the future because the pipelines and the gas are available. You understand? Yeah, so that opportunity, it presents an opportunity. The pipeline presents an opportunity in the future for domestication of the pipelines to various homes when the necessary mechanisms are in place, the necessary policies are in place. You get that? And then your second question is renewables, transition. Yes, Genser we've built wind masts in the eastern region, and we are gathering data, and we are getting wind data, the behaviors of the wind there, and to see how they are suitable to build wind turbines and all of that. We've started the groundworks already. And 2032 there, we will actually zoom into these renewables, right? We are looking at technologies to harvest carbon, right? carbon harvest technologies in our processing plant and all of that to be able to ensure that our fuels are much cleaner and all of that. And you were asking, I think carbon dioxide capture was your third question. Yes, so in a bid to transition to renewables, technologies that has to do with carbon capture are part of our plans, you know, to ensure we do not, to reduce any form of emissions into the atmosphere that will contribute to climate change issues and all that. So I think that answers you, right? Okay, are you sure? Okay. Then your question, your first question, your second question, right, about this cool thing. I decided to major in energy because I'm a civil engineer, and I've decided to continue my career in the energy industry, right? That's why I took an MBA in the University of Cambria solely on energy and sustainability. It's because of the direction I take, right? So the master's program that you want to take will have to be influenced by your decision on the trajectory of your career going forward. If you want to be in this industry, in that industry, it informs you on the kind of capacity you have to build. I thought of building more capacity on energy, you know, so I can be well informed in what I do, decisions I take, affect my knowledge. Still, you know, I'm still trying to learn areas. You need to study other areas like energy laws and all of that, so you're effective. So that is also very important. It's not just for the fun of gathering those certificates, but in terms of how effective you can contribute to problem solving in your industry. I hope that answers you. And then the other question. What's the other question? You are controls and you are a controls and instrumentation person. Instrumentation, electrical engineering, and then you mentioned instrumentation. Good. Is that where you go? You had only instrumentation in what I said. Okay. So the pipeline engineering, you have electrical engineers playing dominant roles in that because power systems are electrical systems. So we have a lot of electrical engineers there. The electrical systems is predominant. And then mechanical systems is also very predominant. So it's not just instrumentation, but the electrical systems, the fiber optic communication systems and all of that. Your field is much more active there. So not just instrumentation, but electricals, instrumentation controls. It's very active there, very predominant.
All right,
Okay.
Before we take the next set, I want to acknowledge our participants who are online. Let's give it up for them. We haven't forgotten you. We know you are there, and we appreciate your participation. Amongst us, we also have a colleague who is a senior lecturer in the Department of Agric, in the person of Dr. Camillus Wagner. If he's here, thank you for coming. We appreciate it. So the next 5 sets. The lady first.
I heard in the introduction that you helped build over 400 natural gas system. I can't commend you less, say congratulations. So with that much of experience, what are the key challenges as long as engineering is concerned in building that infrastructure? And then my second question is there any benefits for females to venture in this field? And do we get, KNUST, do we get any internship opportunities with this? Thank you.
All right. The major challenge in during our construction period were mainly social and land acquisitions. The land is not controlled by the government. The land is for the people, the traditional councils. The availability of those lands depend on the route that we've taken. Will depend. The project depends on the availability of these lands, and you will have to go all out to ensure that the interests of the landowners are met, the interests of the communities where the lands fall are met and respected. The process of getting them to buy into the idea is very challenging. Like I said, when young people like us are approaching them during the stakeholder engagement, they mostly go very defensive, like, why are these young guys, young ladies trying to tell us what to do? Who are you to tell us to give you our land for this price and all of that? So it takes a whole lot of respectful engagement that at the end of the day make sure that their interests are met, right? And all of that. So that's one big challenge that we faced. And another social challenge that we faced was in the communities where the traditional leadership is weak. The people, the individual land stakeholders do what they want. Sometimes they will be very hostile to the project. Even when you are working, they will frustrate you. I want this amount of money for my crops and for my land. I don't care what LVD says. And when you are working and you don't pay attention, we have several instances where they come to the site, block our right of way, stop us from working, seize the Chinese contractors, whoever it is from site from working. So we lose productive hours. That is waste of money and all of that. So these are social issues that we face, but with the right approach to stakeholder engagement, a mix of young and experienced, and try to approach it in a more in an approach that will settle both interests. So that is one issue. And then the ladies are talking about Genser. We are focused on ensuring that the female content, we still have not met what we want. We have a number we still have not met. So we are waiting for you. We are waiting for you. We appreciate the gender balance in everything that we do, right? And it's part of the lender's requirement sometimes. We want to have this percentage of females working here. And we are very committed to that. So we are waiting for more of you, the females, to join, ensure that you are part of the SEO graduate program. Part of SEO, because SEO is the wheel, right? The wheel that can bring you to Genser. So we want more of you to patronize the SEO Africa program so that we can have the opportunity to work with you. So we want more female engineers to be part of the problem solving out there. I hope that answers you.
An internship.
Yes. So Genser, like I said, Anna is here. Anna is the Vice President of External Relations. She's talking, she's having conversations around this. For now, the SEO graduate training program is what we have available, right? If there are special cases of internship, we have people who have approached us for internship with letters from KNUST and all of that, and we've actually found ways to deal with that. So there are intention programs, but not directly with what we do, but we have third-party institutions that we can always connect. I'm not going to talk about that, but we would like you to focus on the relevance of being part of the SEO program right from here. If you don't join from here and you go out there, you have only 2 years. It's very competitive. Your best chance is to join from here, so that right after you leave school, you can go through the process that are required, and you pass whatever it is that you have to pass and join Genser. If you go out there, you have only 2 years. After graduation, after 2 years, you can join. And our program for talent identifications and development is centered within our guided training program. All right. Evidently, we are all part of it. I started from national service, right? Went through entry levels, sectional, health level, functional level, departmental levels, into this executive role. So it's a big example I mean, it's a test to the fact that the process you have to go through to become what you can be, it's real with Genser. We appreciate that. So I will encourage all of you to be part of the SEO Africa program in KNUST to maximize your opportunities out there. Right? Does that answer? Okay, of course. During the engineering phase, right, in as much as we are working with stakeholders, right, trying to meet the technical requirements of regulatory bodies and the owners and all of that, there are some challenges that poses to us that sometimes requires a little bit of compromising. Right. Technically, what I can say is a typical case on the Kumasi project, the pipeline. We had all the right of way until we got to Dunyina to Ahomaso. The area was packed with population, right? And you have no access to Ahomaso. What does it mean? We are expected to, for example, deal with class 1 sizing of pipes to meet our budget, right? The challenge here is that the situation of the population here means that the engineering will have to increase the cost of passing the pipeline through such a dense populated area. So you will have to make a compromise on the class of the pipes and then convince your management to be able to fund that differential increment of the project cost that is influenced by the challenge in this engineering thing there. So engineering is there to solve problems like what they're talking about. What do? We identify the issue on the ground, we develop systems to solve it, we operate, and then we maintain, and then we do continuous improvement on it. So as long as you are engineering a system, automatically you are engineering by considering all the challenges that is posed within and around it. So I don't think I can tell you the specifics of, let's say if you are designing this or engineering this, of course, there are always key challenges. There are always challenges. That's why you have to engineer and have the best specification to meet your budget that you want to build with and all of that. So there are always key issues as long as engineering is concerned, right? I hope you understand. Okay.
Very much, sir.
Okay.
We want to acknowledge the presence of Emeritus Professor Francis Momade. He's at the back there. Prof, give us a wave. Prof, thank you very much for honoring the invitation. We are grateful. The next set of questions will be taken from here. Any more hands from this side?
Hello, I'm Daniel. The theme for today's program was actually Fueling Ghana's Future, Engineering Excellence in Natural Gas Infrastructure Development. Yeah, so with special focus on engineering excellence, and then with your presentation, I heard you say that you flushed the pipelines with nitrogen to eliminate the oxygen. So that means there's going to be some sort of nitrogen oxides of nitrogen some way, somehow in there. So with special focus on sustainability and engineering excellence, how do you deal with these nitrous oxides and oxides of nitrogen? And my next question is, are there sustainable structures or measures for the entire project lines and stuff? Something of that sort. Thank you. Yeah, so my second question is, are there sustainability structures or measures for your company and then, or for your project or your processes? Thank you.
I'll take from Dr. P.O. Teria, then you address, then we'll move on.
All right, my question is very few. One is going to be, how close can the community be to the gas pipeline? Because you do accept that it can be a problem. So how close can they be to it? And what ways do you have in monitoring this proximity that we're talking about, such that there wouldn't be any future explosion somewhere? And then this other one's probably personal to you, but I'm just wondering why at one point in time in your career you were told you are fired. In the sense that for a design, you must convince management about design with all the costs associated. And in a way, they bought into your design. And then you went ahead to implement it. Why then should you be blamed?
Please, you can take them.
I appreciate the questions. So, your first question, the nitrogen oxide. When we pack the nitrogen, we ensure to a certain level of purity. We pack at 98% purity, right? And when we achieve full inert in the system, based on the purity that we want, we have to dispose of the nitrogen oxide content. And we do that through venting. The gas stations that we build, we have vent that can flush, that we can flush anything, whether gas whatsoever through it. If you want to dispose the gas in it, we vent them. So we get rid of this nitrogen oxide content, right, by venting to 1%. You can't get 0. We look at least 1% is okay. 1 to 2% is all right. And when we are done with that, we actually flush lane gas, the first stage, right? And when the systems work at the conditions of the pressure we want from end to whatever it is, that lane gas, we also vent it out, right? So the lane gas actually get rid of whatever content of nitrogen whatsoever. And then we actually we fill the gas pipeline with natural gas and all of that. So that is how we are able to manage the nitrogen packed in the pipeline during the commissioning stage.
Is innate. And the nitrous oxide we are talking about is a breakdown of a chemical reaction. So nitrogen plus oxygen in the atmosphere do not react. The atmosphere is made up of 70% of nitrogen, and the oxygen is there. But the oxygen you are breathing doesn't contain nitrogen. So that is how it works. Thank you.
Thank you. Christian Deborah is our environmental social governance manager. We were able to poach him from Goldfields Mine. So you could see Genser is very strong to poach such a profile from a mining industry. All right. So are you answered? You're okay, good. All right. Sir, you answered, you asked 3 questions. You asked of how we monitor the closest communities or buildings or whatever it is to the right of way. We look out for 200 to be able to select class 1 pipelines. 200 meters away is what we do. So before we do this, we do area survey. We fly drone through the right of way direction that we want. And then we want to look at the displacement or how the set communities are clustered in the path we want to take. So we actually define the route by pushing the route away from the communities, first 200 meters where we can. So majority of our pipelines are actually 200 meters from the nearest community. Then there are areas where we think that 50 meters should be the minimum. Anything within 50 meters to the pipeline is classified as high risk. And anything after 50 meters is more like low risk there. So we can only afford 25 meters. So we acquire 25 meters. And then we use 12 meters for the construction. And then we have 6 meters at least, so that no one could come 6 meters within. That could be extremely risk zones. So what does it mean to go beyond the 25 meters as you've acquired? You don't have control after 25 meters. So what you can do is to try to sensitize the communities so that they can control their activities that are very close to the pipelines. So we try as much as possible that the buildings do not, whatever they do after 25 meters, within so 50 meters is actually medium risk. And then anything inside the 25, like 5 meters, 6 is extremely high. So we tried as much as possible for people not to, encroach the 25 that we've acquired with their buildings or with whatever activities they are doing or farming whatsoever. And when we are done with this pipeline, we have the community relations team in conjunction with the external relations team and then ESG. We do regular monitoring of the right of way by flying drones. We have licensed drone operators in the ESG team, the external relations team. Frick is very good at it. He has a license, and the HSC team as well, community relations team. Jima is here, Diane is here. They regularly patrol the right of way. We also have spies. We've employed over 800 spies. Yeah. We call them the community liaison officers, CLOs. These are people, so we define a community by some indicators, and then we say, okay, we need about 50 community liaisons in this section of the pipe. Their job is to daily walk the right of way to see if there are activities along the right of way that is a threat to the pipeline or the stations, like bush burning, galamsey activities. If people are galamseying within the 50 meters, we can't control everything, but we need to ensure that the activities do not come. And sometimes the issues we have is that we'll be there, and then our control rooms, where we monitor the pipelines and the stations, we've lost communication. And that could be somebody has actually mined or intercepted our fiber optic cable. And Nima and the community relations team will have to go there and see what is happening there. If we see anyone who is deliberately mining close to the right of way, we tag you as an enemy of the, we make sure the community sees you as an enemy of the community. We take you to the custody of the police, and we make sure that you pay for the damage, the fiber optic cable that you've done. It is very clear. So we monitor it by drone, flying, the CLO daily reports. Every day we have a WhatsApp group. They take videos. Those who cannot type, they do voice notes. There is a galamsey activity as Donina or this area. They mine about 3 meters very close to the pipeline, and we train them how to also take coordinates with their phones and all of that. And at the end of the month, we pay them. So we provided this opportunity for the young people there to help us monitor the activities around the pipelines. Yes.
Why you got fired?
Yes, exactly. Yes, why I got fired in 2017? We were very inexperienced in natural gas engineering and right of preparation and all of that. And you know, naturally, when we are transitioning from power to natural gas, our managers are aware that we will make mistakes, right? So before, I got fired because at that time, we had not connected with an EPC contractor who, we were just doing pre-construction activity. We've not even done the construction, so we've not done engineering yet. All right, so we were selecting the right of way. And actually, before the right of way will have to be selected, the engineering of the right of way alignment sheet will have to be approved. That's the first thing. We were not experienced enough. Right, I was barely a construction supervisor who was leading the pre-construction survey works and all of that. I had to go and cross the Ghana gas pipeline 3 times. And I don't know what it means to cross a natural gas pipeline already existing. And our right of way, because we were following a data that was given to us from the top, that was a straight line, 28 kilometers to Takwa. We didn't know that before we start something like that, you have to take your time, study the right of way, do a proper survey, check the topography of the terrain. If the pipeline shouldn't go through mountain, shouldn't go through any active mining concession. You have to study the mining concessions in the Minerals Commission. You have to take the right of way to the Minerals Commission to superimpose onto the mining concessions in that region. So you know that, okay, this pipeline is going through Asanko mining concession, and Asanko plans to develop this area in the future. So Asanko will only be able to mine if they are able to relocate a pipe. And we have, even as we were building the phase 2, right, we had an issue with Asanko mines. But the right thing we did was that we invited the engineers. that we were doing this in this area of their work. And they wanted to come, and they even came to inspect what we were doing. And none of them were able to tell us that the pipeline that is coming from Asanko branch pipeline station to Edika Mines is within a place that they are exploring. So when we built the pipeline and we commissioned and everything was announced, later, after a year, they reported to us that they have explored this area of the land and they want to mine, and therefore we need to relocate the pipes. And Minerals Commission, Energy Commission called us. We met with Minerals Commission's office at Sanko. We sat down and laid the condition. Okay, so you were there. You knew that they were doing some work over there. You came there, so you can relocate at your cost. They couldn't afford it, and it's some of the lessons we learned. So basically, when we are doing this project, we'll have to go the extra mile to go to Minerals Commission to carefully superimpose our right of way onto the latest available map that they have there, to ensure that we can approach or divert the pipelines away from such mining zones to prevent future, conflict between companies like Genser and the mines and all of that. So yes, that is. I think that I don't know whether I've answered and I've added more to it. Okay, so which one? Yeah, let me finish. I think I will fit. Let me finish it. Sorry. So we basically were carrying out. You've been in a position where you are carrying out instruction, but your experience is not there. That you'll have to go back before you touch the ground. Before I took machine to say, let me clear what we have surveyed, I should have done a record study detailing where the pipeline is passing. I should have taken the right-of-way data to Minerals Commission to superimpose which mining concessions I could be dealing with. I should have contacted EPA. I should have done my ECA. I should have gotten an EPA permit before starting that. So self-awareness was zero at that time. I could say that on this project, right? So me as a leader, I believe that inexperience was greatly a part of it. So until I got connected to Sinopec, who were then in Prestia, who did the Ghana Gas Natural Pipeline. I contacted them and I was like, we've done this, we've done that. How did you do this? And then they said, oh, what have you done? So I said, oh, no, don't do it that way. So I went with Sinopec, spoke to their project managers, visited their office in Zema. They showed me how they build the Ghana Gas Pipeline in pictures. First, you do this, you do that, you do this, you do that, do this, you do that. And then we have to step back, retrace our steps. And then these are the things that is usually done. Let's do, the right of way is 30 meters. Before you confirm your routes, you'll have to do this report and then look at the cost that is involved with it. You report it to management, and management gives you their consent to proceed. So if a young engineer, someone tells you, like your manager tells you to go and do this and that, right? He is not a pipeline engineer. We are all getting into it. It is the responsibility of me as an engineer to understand the requirement, the studies that should accompany the starting of the project and the design, the studies that will influence the designs and all of that. Where is the feed? We have no feed. So we touch based on the ground when we had no right to start that work on the ground. The engineering were not established, but we thought as young people we are following instructions. So go and do it, so go and do that, go and do that. And we had to learn to pay the price the hard way. Sometimes the fact that you are fired was, he meant it, right? Because I was in the position where I did not use my common sense. Simple. I didn't use my common sense. Oh yeah, Christian, like, okay, somebody gives you from Prisia to Takwa is 28 kilometers. Then I pick engineers, surveyors. We walked from Prisia to Takwa. We walked climbing mountains and descending, and hey, there's a river here, what do we do, and all that. We didn't have any experience in that. So the first thing I should have done was to study the Ghana gas, natural gas pipeline, how they did it. I should have made a contact. I shouldn't wait for my top management to say, go here and do that. As an engineer who has been trained, critical thinking, go to those who have done it before. Look for those who have done it before. Create a relationship, ask them questions, let them show you how it's done. Then you come back and say, hey, we need to do this and do that and do that and do this. So if I was fired, it was mainly because at that time, I did not use my common sense. It's like putting yourself in a situation where you are blindly executing instructions. So that was it. But I have a very reasonable CEO, right, who has trained me from all the way from national service to what I am now. He is very demanding. He's an ambitious guy, and he loves to see young people paying attention to details, people who are organized in executing their approach, people who are effective. So to say the same person who said you are fired, when I got to my room and I was sleeping, a colleague of mine will call me. Daniela will call me. Henry, are you okay? We heard this. Henry, are you crying? I'm saying, no, I'm not. Then another colleague, then before I realized, Bafo has heard that I'm crying. And then in the evening, he will call me. Henry, stop crying. I heard you are crying. Stop crying and all that. So I paid the price for it. He said, someone will come and do what you're doing. He brought someone to come and lead the project at that time. My colleague came. He left what he was doing to come. And this kind of decisions are very important to let you know that it's not a joke when you are in that position, right? As a young guy, you see as top management, or you see your phone ringing, and then you see that this person is calling you, and you are like, what is going to happen? You know that. But the same person who made that call is the same person who gave me another chance and say, hey, you can make mistakes. Growing doesn't come just by chance. Growth comes when you are given the room to make some mistakes. And then what depends on you is when you know that it is important to learn from the mistakes, right? In the midst of it, make sure that you are humble. If you don't know, you don't know. Don't put up any impression you know when you don't know, because it's always people who don't really know most of the time end up being defensive at what they do. So you even end up exposing yourself. So the more if you want to grow, you have to be humble, right? If you don't know, say you don't know. If you don't understand something, say you don't understand it. If that is the only way. When you make mistakes, know that it's just okay. But make sure that you learn the art of getting someone to mentor your decisions. And mentoring means that you will have to find someone to report to. Okay, I've been asked to do this. Is it, if I do this, if I go through this approach, if I go through this, if I do that, is it okay? Somebody has to supervise your decision making for some time. And when you become aligned with taking sound decisions, taking decision is an act, it's a craft. You will make mistakes along the way. But when you are supervised, when you get a mentor within the corporate environment to supervise your decision making, with time, you will naturally come to a point where your mind operate in a certain pattern when you are taking decisions, and waste will be minimized and all of that. The same person who says you're fired, actually, within 2 months, also promoted me after that. Right. The same person who says that is that same person who gives us the opportunities in Genser as young people to lead. Trust me, if I am to find myself in other institutions, like maybe Ghana Gas or GMPC or other things, I wouldn't have that opportunity to lead projects like that. I will not. But Genser has given us the platform as young people to make some mistakes whilst you are growing. And it is okay to make mistakes. But what you need to do is to learn from it, right? And then with time, you will be extremely good at what you do. So that is where we have come from. From you are fired to an executive role today. Right. But don't be anxious. It's okay. As young people, when you get out there, you are part of a team making decisions, and pressure weighs up on you, and you're afraid that something will go wrong and then you will lose your spot and all of that. It's okay to think like that. But trust me, you'll come to a point where you will feel comfortable to execute what you are doing because you've come to the point where you know your stuff, how to investigate properly, how to work with engineers. You know that from today, even now, when I'm executing a project, I tell my team that every feed, every design, every technical document has to be approved. It has to have a stamp before you touch any work on the ground. So my experience has become a protective shield for them to grow. Guys, do not touch the ground until the engineering document you have has a stamp. The stamp is called approved for construction. If you don't have it, don't touch the work. So my experience today has become a springboard for these young guys to grow quickly. They don't have to repeat what I did. Even this morning, I called them, 3 of them, hey guys, I'm going to tech. What do you think? What are your stories? Is there anything you want me to tell them on your behalf and all of that? They are very effective people now. And they are all young people. And you can also be. So, sir, that is what I can say to your question. Thank you.
All right, thank you very much, sir. A round of applause to him. We will take last 2 questions, and then we are done for today. There will be interactive sessions after here, so please feel free and you walk up to the Genser team to ask any questions. Before, we want to acknowledge some of the team members who came after the first team were acknowledged by Professor Kwanzaa. So we have here Petra Sanyama She. Forgive me if I didn't get your name pronounced well. She's the Social Impact Manager. A round of applause to Petra. We have Christian Deborah, who is the ESG Manager. A round of applause to him. We have Yabonsu, who is part of the community relations. He's the superintendent for the community relations team. A round of applause to Brian Yabonsu. Then we have Benedicta Amponsa, HR Superintendent. You are warmly welcome to KNUST. Our last 2 questions, and we are done for the day. I asked, which people have questions? So it's you and you.
Okay, Mr. Henry, thank you very much for the opportunity and the personal advice. So my question is, as engineers, in as much as we think about the profits, the innovation, the projects, we also have to think about the misfortunes and the things that could go wrong. So you mentioned the domesticalization of some of the projects, meaning that there's going to be the establishment of some of the projects in more communities in the nearby future. So my question is, Thinking about some of the things that could go wrong, you know, as engineers, we are taught that not all processes are 100%. So just in case there's a leakage or there's the possibility of a fire, looking at a community with about a population of 400 or 500 people, we also know that fires always propagate when there's the source of fuel or when there's a continuous flow of, you know, the fuel or the gas. So with this project, just in case there is a misfortune like that, how do you manage that, or are there necessary shutdown systems in place to cater for that problem in the shortest way possible? That's my question. Thank you.
Thank you very much for this opportunity. I want to ask the diameter of the pipelines and how deep they were placed. And also, did you encounter any underground cables or pipes during the digging of the trench? Thank you.
So there's a website called Forage where companies offer job simulations for students to do and then get certificates. So I want to know if Genser would be open to offering such courses, maybe in hopes of preventing what you went through. Thank you.
All right. The first question was if something could go wrong and what measures we have put in place to manage disasters. Okay. Yes, anything can go wrong. There are accidents that can affect and bring up these issues. We acknowledge that, and because of that, first, prevention is better than cure. So our focus is to relate with the communities for them to understand why it is important for everyone to pay attention to whatever they do around these facilities. If we sit and someone just goes there to mine or dig the ground to look for a mineral and then ruptures the pipeline and it explodes, we will be responsible. We will lose our license to operate. The damage will be related to us and all of that. So what we are doing is we put in programs, like I said, the CLOs. Anna, I'm working with Anna. I was working with Anna on a project to develop some kind of, animation programs that we could reach out to the communities with, that will practically inform them that it will take mutual responsibilities, Genser and them too. Whatever they need to be responsible enough or considerate enough to guide whatever activities they do around the pipeline corridors or where the pipelines and the stations are. So for example, the drone mechanisms we put in place is to monitor activities that are a threat that could spark disasters like that. Even if such disasters happen, we have what we call the block valve stations, right? At every 25 kilometers, we put a block valve station. And when there is a damage done to a section of the pipeline, we block the flow. As you said, if there is a flow of gas or flow of fuel, there will be escalation. So we block the flow of the fuel from where the issue is to ensure that the issue doesn't transmit to the other healthy part of the pipelines. So the block valve station's responsibility is to cut off the flow of fuel when there's an issue so that we could deal with a particular section of the pipeline, right? So aside that, if we just sit back and not care about what the community does around the pipelines, this becomes a time bomb. With time, we'll have issues. So we work assiduously to ensure that there is adequate sensitization, ensuring that the communities understand what it means to cohabit with natural gas assets or pipelines and stations. So that is a continuous collaboration that the operations team and the external relations team and the community relations team, that's a job Yabonsu does all the time, you know, and all that. So there is this continuous collaboration in terms of stakeholder engagement with the owners of the land where the pipelines are and what they do there to control some of these things. But we learn from case studies out there how pipelines are affected and even explode. But even if they do, natural gas pipelines is unlike diesel. Natural gas is lighter than air, right? So when there's a leak, natural gas actually get carried by the air up there. Unlike diesel where there's a leak, it falls to the ground because it's denser than air. You understand that? It's one of the characteristics of natural gas that makes it even much more safer than the use of diesel, heavy fuels and all of that. So those are mechanisms we put in place to reduce disasters or prevent it. Is it answered? The next question. Who was that? Your question was the diameters and the depth. Okay. Well, the diameters for the pipeline we use ranged between 7.8 to 14 mm. 14 mm, the diameter, the thickness of the pipelines. And the diameters, we've built 12 inches, that's 300 mm. We've built 20 inches. We built 24 inches. So far. So all the branch pipelines we have that feeds the power plant directly are all 12 inches. And all the main transmission pipelines are 20 and 24. We call them primary pipelines from Pristia to Kumasi. The Kumasi pipeline within the Ashanti region is 24 inches. That was quite bigger than the previous 20 inches we built to Seshubekwai, Western North. Is that clear? The diameters, the depth of the pipelines are between 1.7 to 2.5. The 12 inches pipelines are buried at an average depth of 1.7 meters. And then the 20 inches to 24 pipelines are buried at an average depth of 2.5 to 2.7. Averagely 2.5 for primary pipelines, 1.7 for branch pipelines. That is for the 12 inches. Right? And when you bury them, we have something we call, hydroprotection. Hydroprotection is putting in measures to control erosions. They are vulnerable as areas of the pipeline which can easily erode and get the pipeline exposed. One of the issues we've had with the surveillance of the drones and CLOs are pipelines that get exposed by runoffs, right? Sometimes because of the gradient of the area we are burying the pipe, the speeds of the runoff are high to the extent that with time, after 3 months or whatever, it erodes it small onto the pipeline. The first layer or the first caution tape is exposed, or the pipeline itself. We've had countless issues on this. So we monitor to ensure that areas where pipelines are buried and vulnerable, we put in place effective hydroprotection mechanism. Sometimes we have to, protect the slopes with concrete, right? Where the runoffs could have higher speeds and cause damage, we cast concrete over those areas to ensure that the pipe are exposed by erosion. And these are issues you will have most of the time. So after construction, or during the construction, we have to make sure that there is adequate hydro protection throughout the right-of-way to minimize possibility of exposure in the future. And even if they are exposed, we have procedures approved to ensure that all those pipelines exposed are covered back. And then we implement erosion control mechanisms to reduce some of these things in the future. I hope you are clear. Good. Then the third question, what was the third question? Internship, programs, certification programs, possibility of Genser having certification programs online. During what? Job simulation courses. What are you talking about? What are you talking about? Can you explain?
Thank you so much for the question. I'm Anna, by the way, that Henry's been referring to me throughout his presentation. So at this point in time, we will not be looking at any simulations, but I love the idea and I'd love to chat more with you, maybe after the session, because it's not something that's been on our radar up until now. I'd say right now, if you have the opportunity to be part of Fritz's industrial training program, that's probably where you get most hands-on experience and also the opportunity to ask all the questions you've always wanted to ask to plant managers. I think I might round up this session by just having a couple of comments. Thank you so much for sharing your experience, Henry. I learned a couple of things from your presentation about you yourself, your career trajectory, as well as some very specific engineering as well. So I am not an engineer, but I have a pleasure of working with a group of, I think we're close to 320 up until this point. And I think, as you go through your studies, you'll be graduating one day and you'll be really excited to be engineers. Your parents will be excited, your extended family will be so excited to have engineers, and then you'll be finding yourself in your new job. And I think that what universities may not really be fulfilling, and it's a hard thing to get, is really how do you work in a corporate environment, right? So right now they're teaching you about theories and how to apply them, and you might say, oh yes, this is part of the drawing, this is how things are supposed to be in the classroom. But how does that actually translate when you're in the field, right? You might have instances where your boss is trying to get hold of you for the entire day, but he cannot because he can't find you because you're in such a remote area and you don't have access to internet. The amount of change that goes on in upper management sometimes is astounding. So you might leave work at 7 a.m., you come back at 3 p.m., and everything has changed, right? And so how do you manage your colleagues? How do you manage the internal politics? Nobody really prepares you enough for that. I think we're still learning every day on how we work with that. We are still, I'd say, we're not the big energy companies in the world. Maybe one day we will be. But also as we are growing as a company at Genser, we're also seeing those changes, the dynamics, the soft skills. How do you manage up? How do you manage your boss, right? To make sure that he looks the best way that he can. Because if you do, they will end up protecting you. And I think that's something that we saw from Henry's examples earlier today. And in terms of the SEO program, so I know that there's a lot of questions about internships, participation certificates, and really to help you advance in your careers. So if you want to have an opportunity to work at Genser, as Henry could not have said more, is really through the SEO program. This is where you'll have the best chance of really getting that hands-on experience. It's an 18-month rotation, 6 months in 3 different departments, and you'll come out with And I'd say from day one, you really get that experience. Isn't it so, right? And then for females, we love to see more female engineers. We really encourage that participation. And if you don't get accepted the first time, apply again, right? We have a great story online. I just found out the other day that one of our female engineers, Mary, who's stationed at the GCP, she applied, I think it was on her third try she got accepted. So perseverance really, really pays off. And we would love to have more internships, but I'd say the number one reason why we cannot is due to the very remote areas that we operate in. So it's housing, right? We would love for all of you to come, but just the location of the places, people need a place to sleep, and so that is our biggest limitation right now. But thank you so much for Henry, and thank you all for coming. It's been really a great day. Thank you.
All right, let's give it up for him. There was a question online, Henry. So I think that she touched on one. Somebody was asking for you to talk about the SCU, which she has. Someone is asking if there is any at Takoradi Technical University, because you mentioned there is one here. Is anybody aware of it? Is anybody a member? So somebody is asking, Takoradi Technical University, do you have a representation there? That's the only question online now.
Yes, so we've been working very closely with KNUST, UMAT, TTU, and also the University of Energy and Natural Resources. We are working so Fritz is handling that relationship and inviting people to come. And obviously, anybody across West Africa is welcome to apply to the SEO program.
All right, thank you very much. Let's give them a hand of applause. Thank you so much. So I'll hand over the microphone to Professor Kwanzaa to give the closing remarks.
Thank you. So thank you very much, Dr. Ella. And I give these remarks on behalf of Professor Francis Kemalswo, who deputized for the provost. We've been working towards this day for some time now, and we are truly grateful that it did happen. We're grateful that it has happened. Today, we've had a truly engaging interaction with Genser, starting with Fritz, who took us through internship opportunities and what the story has been. We've gone on to have what I consider to be real deep conversation with the Vice President, Operations, Mr. Henry, let me check the name again, Henry Abeku Opon. So Henry has shown us that in handling such projects of that magnitude, you require multiple skill sets. The challenges range from engineering to sociological, linguistics, etc. So he's told us in the place of work, not only DY, DX, and Anna just mentioned that the transition is not something that you would acquire in your 4 years here. So you commit yourself to lifelong learning, and the workplace offers that. Our keynote speaker touched on key things such as stakeholder mapping. So if you want to implement real engineering projects, you should have a good idea of who and who are involved. So in their case, they needed to talk to the Minerals Commission, for instance, because pipelines were going to pass through, were likely going to pass through concessions. So have you given any concession in our right of way? You needed to talk to the EPA. And I suspect they probably even needed to talk to some of the utilities, because you need to know where water supply lines are passing and things like that. So we've been challenged to pay attention to the soft skills as well. Teamwork. He says he learns from those above him, and where else? Those who report to him. So he learns, he's always learning. This is something we should keep in mind. Learning never comes to an end. And more importantly, you even learn from your mistakes. So learning goes on without end. Attention to details, very important. Sometimes some people are even copying work from their friends and they copy the index numbers. You don't pay attention to details. So critical thinking is required. Critical thinking. So while we master Bernoulli's equations, while we master the stresses and thermodynamics, critical thinking, continue asking questions. So we are very happy that this day has happened. There will be a more formal vote of thanks, except to say that on behalf of the provost, we look forward to continued engagement with Genser. I'm happy that you're already talking to the Department of Agri-Economics. We've said that we want to bring all of KNUST on board. So we are an entry point to a much larger ecosystem with 85,000 plus students and 6,000 plus staff. So there's a lot that we can do by teaming up. Just before coming, I was told that Genser actually has an MOU with KNUST, and it was to support students in the medical school. So hopefully, at some point, Genser would also be supporting students in engineering. On this note, I conclude my remarks and hand over to Mrs. Kwao.
Thank you very much, Prof. Now I'll call on stage the president for the Ghana Engineering Students Association in the person of Honorable George Adudaku. A hand of applause for him as he comes to give the vote of thanks. That's an honorable. Please keep clapping.
Wow, this is inspiring. I think our speakers deserve a big round of applause. Good afternoon, distinguished guests, my fellow engineering students in training, ladies and gentlemen. On behalf of the College of Engineering, the Brew-Hammond Energy Center, the KNUST Engineering Education Project, the Ghana Engineering Students Association, KNUST, I extend our deepest appreciation to everyone who made today's program a resounding success. To our speakers, Engineer Henry, Abeku Opon, Engineer Fritz, Moses, Anna Clapper, and the Genser team, thank you for sharing such rich insights and practical knowledge. Your thoughts on fueling Ghana's future, engineering excellence in natural gas infrastructure development, have not only enlightened us, but also challenged us to think critically about the role of future engineers in Ghana's industrialization journey. To our partners and sponsor, Genser Energy, we are grateful for your continued collaboration and for showing us the real-world impact of engineering on national growth. To the college leadership, faculty, staff, we appreciate your guidance and constant support in shaping us into competent and responsible professionals. A special thank you to the organizing team and volunteers. Your hard work behind the scenes has made this program seamless and impactful. And to you, our fellow students and participants, thank you for showing up, for engaging, and proving that the future of Ghana's energy sector is in passionate and capable hands. Let us leave here motivated to innovate, to collaborate, and to contribute meaningfully to Ghana's development. Thank you once again, and may God bless us all.
Thank you very much. Honorable God. Mr. President, please keep clapping till he sits. All too soon, we have come to the end of this eye-opening session that we have had today. And let's take a closing prayer, and then I will announce the order of photography. Then we are out of here. Let's bow our heads in prayer. Our Lord Almighty, we are grateful to you for a beautiful program. We commit our sponsors and our partners, Genser, into your hands. We pray that you continuously help them in all their endeavors. Our speakers, all the members that came here, we pray that you will continuously support them and give them strength, the knowledge that they will make significant impact in the nation we find ourselves and beyond. We pray, we commit ourselves as a college that you continuously help us for more partnership to help build our students to be professionals that will benefit society. We thank you, Lord, and we commit everybody into your hands. Wherever we move away from here, we pray that your light will continuously lead us to our destinations and our lives beyond. We thank you, we bless you. In the mighty name of Jesus have we prayed with thanksgiving. Amen. So we'll take a photograph first with Genser and the staff of KNUST College of Engineering who are here. Please come for a photograph together. Please, the committee members, you also start putting yourselves together. You are the next. Genser, please. Wine. The women in engineering here, please, I learned there's going to be a special one also with the ladies from Genser. So if you are a female, a woman in engineering, you can also wait. Please, students, why are you leaving? Your time will come. Please come on stage. The Genser team and KNUST College of Engineering staff, anybody who is around, kindly come on stage.